students, welcome to Earnest Academy. Myself Anjali Muralidharan and I am going to take a session on FCFS scheduling algorithm. Okay, what do you mean by FCFS scheduling algorithm? It is first come first serve scheduling algorithm. Before moving on to that, I am going to tell you what is scheduling. Scheduling is nothing but whatever process is available in the ready queue, we are going to allot CPU for that processes. Whatever process is available in the ready queue, we are going to allot CPU for that particular processes. That is known as scheduling. Okay, for better utilization or maximum utilization of the CPU, we have different types of algorithms available in scheduling. Okay, from that, one of the famous algorithm is known as first come first serve scheduling algorithm. So from the name itself, we can understand that what is first come first served. First come first served is nothing but whichever process is coming first, servicing it first. Only after completion of that particular process, another process is taken from the ready queue. So first coming process is serviced first, or we can say that in which order the particular process is arriving in the ready queue, in the same order we are getting it treated in the CPU. Okay, that is what is known as first come first serve scheduling algorithm. We are moving to an example of FCFS. FCFS is nothing. Here we have four different process available in the ready queue. We have four different process available in the ready queue, and its arrival time is there as well as its burst time is there in the there. Okay, what do you mean by arrival time? Arrival time is nothing but in which time a particular process is arrived at the ready queue, that is known as arrival time. In which time a particular process is arrived at the ready queue, that is known as arrival time. And burst time is nothing but how much time is required for a particular process for its completion. Okay, how much time is required for a particular process for its completion, that is what is known as burst time. So here we have given with arrival time as well as burst time. Arrival time is in which time a particular process is arrived at the ready queue, and how much time is required for the completion of the process is known as its burst time. So here we are going to solve it using FCFS, and we have given with the Gantt chart. So using Gantt chart, I will show you how to process this particular or how to allot CPU for these particular processes. Okay, now Gantt chart start at time 0, and it check, or the CPU check whether there is any process available in the ready queue at time 0. Yes, there is a process P1 available at 0. No other process is available. So here we are going to allot P1 or allot CPU for process P1, and its completion time is 2. After time 2, the process P1 is getting completed. So we are going to check the ready queue whether there is any another process which is available at time 2. Yeah, there is a process P2 which is arrived at time 1, and it is waiting for a CPU to get executed. Okay, so we are going to give a chance to process P2 to get executed in the CPU, and its burst time is 2. So after 2 amount of time, the process P2 is getting completed. So it arrived at time 1, and it gets the CPU at time 2, and it is going to complete its execution at time 4, because it needs a 2 time for its, or 2 time as its burst time. So after 2 amount of time, it is going to complete its execution. So at time 4, it completes its execution. At 4, the CPU is going to check whether there is any process available in the ready queue at time 4. No process is available at time 4. So the CPU is going to an idle condition till 5, because at time 5 there is a process P3 is arrived at ready queue, and CPU is going to execute P3, and its burst time is 3. So after 3 amount of time, it completes its execution. At time 8, P3 completes its execution, and CPU again checking whether there is any process available at time 8. Yes, there is a process P4. It is arrived at 6 and waiting for CPU for its execution, and we are going to give some amount of time, or give a CPU for process P4, and it completes its execution at time 12. So this is how FCFS is working. That is, first coming process is treated first. After that, the second coming process is treated. After that, third one is treated, and after that, fourth one is treated. So in which, according to its arrival, we are allotting CPU for the processes. Only after completion of one process, another process is getting the CPU. So this is what is known as FCFS. And now we are going to calculate the completion time. What do you mean by completion time? Completion time is nothing but in which time a particular process completes its execution. In which time a particular process completes its execution. Here, the P1 completes its execution at time 2. P2 completes its execution at time 4. P3 completes its execution at time 8. And P4 completes its execution at time 12. So here we are going to write the completion time of each processes, that is 2, 4, 8 and 12. So in that way we have written the completion time of each process. Now we are going to calculate the turnaround time. Turnaround time, that is how much time each process waiting for its CPU. That is completion time minus arrival time. That is completion time minus turnaround time. How much time it is utilized to the CPU. That is completion time minus arrival time. Okay, for each process we are going to calculate the turnaround time, which is nothing but completion time minus arrival time. That is, here it is 2 minus 0, that is 2. Here it is 4 minus 1, that is 3. Here it is 8 minus 5, that is 3. And again it is 12 minus 6, that is 6. Okay, that is turnaround time is equal to completion time minus arrival time. Okay, completion time minus arrival time. Okay, so that is how much time it waited in the ready queue for the CPU. Okay, nothing but how much time it is utilized the CPU. How much time it is utilized the CPU. That is, here it is 2 minus 0, that is 2. Here it is 4 minus 1, that is 3. Here it is 8 minus 5, that is 3. Here it is 12 minus 6, that is 6. So that is what is known as turnaround time. Now we are going to calculate waiting time. What do you mean by waiting time? Waiting time is nothing but it is turnaround time minus burst time. That is how much time a particular process wait for getting the CPU. How much time a particular process wait for getting the CPU. That is what is known as waiting time. So waiting time is nothing but turnaround time minus burst time. So we have calculated waiting time for each process, that is 2 minus 2 0. Here it is 3 minus 2 1. Here it is 3 minus 3 0. Here it is 6 minus 4 2. So this is what is known as the waiting time for each particular process. Now we are going to calculate the response time. What do you mean by response time? Response time is nothing but on which time a particular process gets the CPU minus arrival time. On which time a particular process gets the CPU minus arrival time. That is, here it is 0 minus 0, 0. Here it is 2 minus 1, that is 1. Here it is 4 minus 5, that is 0. And here it 4 minus, here it is 4 minus, sorry, 5 minus 5, that is 0. Here it is 8 minus 6, that is 2. So in this way we have calculated the response time. That is, on which time it gets the CPU minus its arrival time. That is known as the response time. Now we are going to calculate the average turnaround time as well as average waiting time. What do you mean by average turnaround time? Average turnaround time is nothing but average of turnaround time of each process. That is total turnaround time by number of process. That is, here it is 2 plus 3 plus 3 plus 6 divided by 4, that is 3.5. And the average waiting time is nothing but total waiting time by number of process, that is 3 by 4, that is 0.75. So now I think that you all understand what is FCFS and what is the turnaround time, waiting time, response time, completion time, burst time and arrival time of FCFS and how it is getting calculated. So everything is clear, and today I am going to sign off. Thank you.